Here is the video answer key to the 5 trig equations that I presented to you guys in class on Friday. First one, 3a. Sine theta cos theta equals sine theta. Okay, you might first be inclined to divide by sine theta here, but like I said in class, if you do that, you're going to lose some of your solutions. Kind of like how you can't divide by x if you were solving an equation like x squared equals 5x. If you divided by x, you'd be left with x equals 5, but you're losing one of your solutions when you do that, okay? So what you really have to do here is take away the sine theta. So we're left with sine theta cos theta minus sine theta equals 0. And then do some factoring, okay? Now generally with any trig equation, you want, if possible, you want to write the equation with only one trig expression. So if possible, writing everything in only sine or only cosine. But in this case, you can't do that. You can't change sine or cosine to anything but their reciprocals. Like sine, you could change to 1 over cosecant or something like that. But that's not going to get you anywhere. So in this case, you want to just set this equation equal to 0 and then factor. With this term and this term, there's a common factor of sine. So you can just factor out sine theta. What you're left with is, well, sine theta times cos theta would give you the first term, and sine theta times 1 would give you the second term. So this is how we would factor it. Now that it's factored, we have this times this equals 0, so we set each factor equal to 0, and we solve, using what we know about the unit circle. So sine theta could equal 0 itself, or cos theta minus 1 could equal 0, or cos theta could equal 1. So ask yourself now, where is the sine, or the sine of what is equal to 0? Well, the sine is 0 at the start, at 0. So theta is 0. And we're talking about on the interval 0 to 2 pi. Okay? So theta of 0 solves this equation. And for this one, where is cosine equal to 1? Well, also at 0. So we have just one solution to this equation, and that is 0. Theta equals 0. I mean, it depends how the interval is written, right? If the interval was, if you could include 2 pi, well, 2 pi is also a solution, but 2 pi is coterminal with 0. So I think on the interval 0 to 2 pi, it's sufficient just to write 0. Okay, so that's 3a. Now, 3b. We have a cosine squared and then also just a linear form of sine. Okay, that's not good. You don't want them together. Now, just keep in mind that this sine squared theta plus cosine squared theta equals 1 is a key Pythagorean identity that we can use. Anytime you have a squared cosine or sine, you can really easily replace that with the other. So cos squared theta, if we just take away from the actual identity, if we take away sine squared, then we're left with cos squared theta equals 1 minus sine squared. So we can just substitute. We can substitute the 1 minus sine squared in for the cosine squared and then have an equation with just the one function, just the sine. So now we have 1 minus sine squared theta minus 2 sine theta equals 2. Now we're solving a quadratic equation. It's kind of hidden in here. So I would set one side equal to 0. I'm going to let the left side equal 0 to make all these values positive. Okay, so we'll have the sine squared, and then we have, take away the 1, and we add the 2 sine. So taking away the 1 from the 2. We're left with 0 equals sine squared plus 2 sine theta plus 1. And we can factor this. Just sine theta plus 1 times the same factor again. Right? Just to show you how I did this. Sine theta times sine theta would be sine squared theta. And then sine theta times 1 is 1 sine theta. Here's another 1 sine theta to make the 2 sine theta. And then 1 times 1 is 1. Now because we have the same factor twice, we've only got to solve one equation. Sine theta plus 1 equals 0. So sine theta is -1. And now ask yourself, all right, where is the sine equal to -1? That just happens one time in the first go-round, the first wrap. That is 3 pi over 2. So theta equals 3 pi over 2 is the answer to letter B. Now, 3C, kind of out here. 4 sine theta equals cosecant theta. Well, in a similar way as we did with 3B, when you have two different trig functions, you want to try, your first step should really be to try to write the equation with just one function. And you can do that here. Because these are reciprocals, you can really change, well, either one. I would probably recommend changing the cosecant theta. So we have 4 sine theta equals 1 over sine theta. Remember that cosecant is the reciprocal of sine. So we can rewrite cosecant as 1 over sine. Now to solve this, I would multiply both sides by the denominator, which is sine theta. So this becomes 4 sine squared theta equals, well, the sine thetas here cancel, equals just 1. And then personally, I like to solve this by factoring if possible. You don't have to. You could divide by 4 and then square root. But in doing that, you've got to remember to include the plus or minus after you square root. So you won't have to worry about that if you solve this by factoring. So I'm going to subtract the 1. We get 4 sine squared theta minus 1 equals 0. This is a difference of squares. Right? 2 sine theta plus 1, 2 sine theta minus 1. And just to kind of, again, show you what I did, this is like 4x squared minus 1, right? How would that factor? 4x squared minus 1 would be 2x plus 1, 2x minus 1. So we have 4 sine squared theta minus 1 is 2 sine theta plus 1, 2 sine theta minus 1. Now we have two different factors. We've got to consider where either one might be 0. 2 sine theta plus 1 is 0. And we also have to solve 2 sine theta minus 1 is 0. Am I still on the, yeah, okay. Take away 1, divide by 2, so we have sine theta equals -1/2. And here, add 1 and divide by 2, and sine theta is +1/2. So theta can be, let's see, the sine of what is -1/2? Well, what, 30-degree reference angle in the third and fourth quadrant. So we have 7 pi over 6 and 11 pi over 6. That's for where the sine is -1/2. For +1/2, it's a 30-degree reference angle in the first and second quadrant. So we have 5 pi 6 and the first quadrant 1 pi over 6. So all 4 of those solutions we've got to include. Okay? So those were the first 3 problems from the homework. And again, the B and C are more similar than A was, right? Where you can replace one of the function values to use the same type of function. You want to try to do that. You want to do that first. But in letter A, we couldn't do that. Sine and cosine, you can't use the Pythagorean identities unless you have sine squared or cosine squared. Okay, if you just have regular sine and cosine, you got to figure out a different way to do it. And in this case, we just took away sine and then factored and stuff. Right? The last 2 problems, they're very basic unit circle problems. Just to kind of speak through this, 3D, you ended up, if you solve for sine theta, get sine theta by itself, you get sine theta is √2 over 2. So theta equals pi over 4 and 3 pi over 4 for problem 3D. For 3E, you get sine theta by itself, and you end up with sine theta equals -1/2, and that happens, again, with a 30-degree reference angle in the third and fourth quadrants. Sine theta equals -1/2. So you have 7 pi over 6 and 11 pi over 6 as your answers for 3E. All right? Have a nice weekend.